Hey everybody, so today I'm going to be going over a USACO bronze problem called the Bovine Shuffle. Now this is a basic simulation problem, and basically there are N cows and they perform some sort of shuffle, and their positions are marked with 1 to N, and we have to find, the input is N, the number of cows, and then the N numbers, which is the shuffle sequence. And then also, let's see, the order of the N cows after 3 shuffles. And our output, or what we're trying to find, is the order of the cows before the 3 shuffles, so the initial position. So this is the initial position, the sample output, and then after 3 of these shuffles are performed, then we get this position. But we're only given this position, so we have to kind of do a reverse shuffle 3 times. So I'll start off by, let's write these numbers down. So the sample input, our shuffle sequence is 1, 3, 4, 5, 2. And I'm going to refer to these just by their first number since they're all distinct. So this one is just going to be 1, 2, 3, 4, 5. So let's see here. So at position 0, or after 1 shuffle, or after 0 shuffles, meaning the starting position, this is after 1 shuffle, this is after 2, and this is after 3 shuffles. So we are given this, it's 1, 2, 3, 4, 5. And we know that this is 1, 5, 2, 3, 4. 1, 5, 2, 3, 4. Alright, so what we need to do is, so let's start by trying to simulate an actual shuffle. So I'll move this over here. Okay, so let's think what's going to come after this. So after 4 shuffles, what happens? 1, it'll still be 1, and then this goes there, so 1, 5, 2, 3, 4. Now let's think about what exactly we're doing and what a shuffle would look like. So I'm going to think, okay, I'll write down 1, 2, 3, 4, 5. And after this, we'll have 5 numbers again in a different order. And I'll mark these with position 1, 2, 3, 4, and 5. So this is just the position. So what we're looking at is, okay, what we do is we look at this number right here, and then we look at this number, and we put this in the position that this says. So this says position 1, so we take this 1 and we put it in position 1. So this will go here. Next up, we look at this number, and then we look at this number, and we see this is position 3. So we take this number, and then we put it in position 3. So actually, I'll use pink for this. So this is going to be position, or this is going to be the number 2. Next, we look at this 3 right here, and it is saying this should go to 4. So we put this 3 in position 4. And the same thing for 4, we go to position 5 here. And finally, this number 5 is supposed to go to position 2, so we bring this 5 over here, right in there. And that is 1 shuffle. And as you can see, that is what we had here for our 4 shuffles. So 1, 5, 2, 3, 4. Now, let's think about what the code looks like for this kind of shuffle. Now, the way I see it, we have 3 different sets of numbers that we're dealing with. So we have our sequence, or our shuffle, and this remains constant. This is just the shuffle that's given, and that's what is used to determine what the next order will be. And then this is our initial order, and then this is the order after 1 shuffle. So we have 3 arrays because these are sets of numbers, so I'd like to think of them as arrays. So let's say this one is going to be shuffle array, I'm just going to call it that. And then we'll call this one order. And then this one, this new array that is going to represent the next shuffle, is going to be called new order. So this is the shuffle, and then as you can see here in our scenario, this is the order array, and then since the next one is, oops, this, let's see, right, this is the new order array. So now let's think about what we're doing from a code standpoint. So we look at our order right here. We look at, okay, so order is the value. Actually, let me clear this out. And then now that we have our new arrays, I'll say, okay, shuffle, shuffle 1, 3, 4, 5, 2. Order is going to be 1, 2, 3, 4, 5. And then new order is going to be some value. I should do these in this color. So do that right there. Nope. Copy this and paste. And then this one is new order. So what we're doing is, okay, we're looking at this order value. What is order at position? And notice how we're iterating over each element. So that should tell you that we're going to be using a for loop that is going to go from is going to go from 0 up until, but not including n. So first we look at what is right here. So we're going to look at order at, let's say, 0. And then now we're going to look at this, what is at the first spot in shuffle. So shuffle at 0. We have shuffle at 0. But the new array that we're actually creating is new order. So if you think about it, what do we have when we are setting values for a new array? So we're going to have that new order, and then we will have some sort of index right here, which is the index that we're putting our new, the index of the new position or new value in our array. And then we would be having an equal sign, and then some sort of value right here. Yeah, some sort of value right here. So whatever is here will be that value that this element in new order will be. So when we are so we know that our first value right here is supposed to be 1. But now let's say we're looking at 2. So let's say order at 1 is 2. We're looking, okay, what is the position that this 2 goes to? The 2 is supposed to go to position 3, right? So since this shuffle is telling us what position that we want to be putting our order value at, well, first of all, notice how the order is the thing that's giving us the values. So we know here that the value that we will be using, that whatever this is will be equal to, is going to be that order at I. And then we have the position is told to us by the shuffle. So inside of here, we would have shuffle. And then let's see if I have enough space at I. So this gives us our shuffle. But one thing you might notice is that this shuffle tells us Okay, go to position 1. But in Java, arrays start from index 0, and then they go 0, 1, 2, 3, and so on. So when this says position 1, it actually means position 0, index 0. So we need to shift this 1 down. So this 1 actually means 0, and this 3 would actually mean 2, and this 5 would actually mean 4. So inside of here, let's just write over it. We would actually have our shuffle I minus 1 inside of the brackets. And so this code simulates one part of a single shuffle. So if we wanted to do this for all 5, then as I said earlier, we would be having this for loop right here, which would go from 0 to n. And then we would have this code inside of it, and that would that would simulate one shuffle. So let's see this in code. So I have my template code right here. Let's start by reading in the inputs. So first up, we have n. Basically, already have that. Now I have 1, 3, 4, 5, 2. I want this to be an array, as I said. So I'll call this shuffle, and it's of size n. And so I'm going to read it in now. Shuffle at I is going to equal. Well, I'm reading in the next line, and then integer parse int token. So now we've read our second line of input, and then the third line will be the same thing. It'll just be called a different array. So we said we would call this order, and now we have our 3 inputs. Now notice how we have 3 arrays here, so I'm going to create a new order array. Int new order equals new int n. And let's see, so now let's put this code in, new order shuffle I. But if we're going to be using this I variable, then we need that loop. So we have for int I equals 0, and then up until n. And now we have new order at position, new order at shuffle I minus 1 equals order at I. So I did this now, and this should simulate one shuffle. So I'm going to print out what order is right now, and after that I'm going to print out new order. Alright, and when I run this, let's see what happens. Oh, oops, I forgot to put in my input. So I paste that in there. And now let's try running it again. Ah, forgot. Arrays toString and arrays toString. Okay. Alright, so we have this is after 3 shuffles, 1, 2, 3, 4, 5, and then this is after 4 shuffles, because it just does one more shuffle. 1, 5, 2, 3, 4. And we saw that. So now this did a forward shuffle. But what if we wanted to do a backward shuffle, meaning we wanted to go from after 3 shuffles to only after 2 shuffles? So if we think about it, it would really just be the opposite of what we have here. We would be setting our new order to be equal to whatever this is at position shuffle I minus 1. So reverse shuffle would actually look like order I equals, and then what do you think is next? Well, it would be new order, and then we would, I don't really have space here, but it would just be this same exact thing, shuffle I and then minus 1. And so it's the same thing, it's just we flipped what was on which side of the equal sign. So let's try doing that now. I'm going to maintain the, actually that's fine. No, yeah, I will maintain the names of new order. So I'm going to keep new order in here. And so really all I'm going to be doing is moving what's inside here. And I'll call this I, and then this will go into there. So now if we were to do that, we start off with 1, 2, 3, 4, 5, but if we remember, a backward shuffle, meaning after 2 shuffles, would have led us to 1, 3, 4, 5, 2. So now that we know how to do one backward shuffle, we just have to repeat this 3 times. So I'm going to do, let's see, 3, and then now we have this. Now let's try running it. I'm going to paste that in there so that we can see what the new order is like after every single shuffle. Now the issue, you might see here that it's just repeating the same exact thing over and over, 1, 3, 4, 5, 2, 1, 3, 4, 5, 2. The issue is that we do set this first, so new order is not anything, but order is this. And so we do set new order to be equal to some sort of thing here. But then after we print out our new order and then we go to our next iteration of the loop, this order value is still the same because order was never changed. But we want to be accessing the most recent version of new order, not the original, which is what we took in as an input here. So after this line, we actually need to set order to be equal to whatever new order was, but we're going to need to create a clone of it because we don't want it to reference the same thing. So now if we were to try it, then we would end up with 1, 5, 2, 3, 4, and so this is after 3 shuffles, this is after 2 shuffles, this is after 1 shuffle, and this is after 0 shuffles. So now I'll remove this, and let's use another for loop to print to our output. And we're just going to do print ln new order at I. And let's run this through our USACO grader. Just make sure we have no print statements. Oh, here we go. And let's see here. Shuffle.java. Oh, looks like they're on file. Okay. It's just messing up a little bit. That's fine. File name too short. What is this? File name too short? Okay. Is this the right shuffle.java? Submit solution. Okay, must have been some sort of bug. And we have all 10 test cases. So this was the bovine shuffle problem, and it was one of the typical kind of problems that you see in USACO Bronze, which is a simulation problem.